Once again, welcome to my YouTube channel. I want us to study physics paper 1. Physics paper 1, the paper that they did last year, 2025. And we're going to revise for section A. Then when we get time, we shall study on section B. Section B, that is having 25 marks. 55 marks, I mean. But today we want to study, that is section A. So the first question is asking a microscope screw gauge with an error of positive 0.02 millimeters shows a reading of 0.31 millimeters when used to measure the diameter of a steel ball. Determine the actual diameter of the steel ball. So we want to look at how we go about that question. If you are asking a question like that, you need to know about the errors that we are having in such kind of micrometer screw gauge. We have negative and positive errors. So whenever you are asked of physical, that is positive errors, then it means you are going to subtract to get the actual measurement. But if it is negative error, then you are going to add to get that is the actual measurement. So that's what we want to look at. So this question, I'm having positive error. Then if it is positive, then we are going to add so that we have that is a positive, that is actual measurement. Now, so we are having, so you are going to take just 0.31. So you are going to add it, you are going to subtract it. So we subtract it, sorry for that. I want to subtract it. So subtract, we are having 0.02. And the answer you're going to have, because we're having positive, then you are going to have the answer as, that is 9 to 0.29 millimeters. 0.29 millimeters. As simple as like that. Now, question 2. Question 2 is talking about, so for this, students want to cut down a tree without destroying any of the houses around it. Describe how students can estimate the height of a tree using the word here is the height of a tree, using the height of the student to safely cut down the tree. Now, this is a question in Form 1, how we estimating the height of trees even without measuring it. So the first thing you could have done is just to measure. You come out, you have to measure the height of that particular tree. You measure that is I mean the shadow, the length of the shadow of the tree. You go and measure the height, not measuring the height of a tree, rather, because that's what I ask. That is you take the shadow of the tree, the measurement of a student, the height, and also the shadow length of that particular student. Then you apply the formula so that you are able to find out the height of a particular, that is the height of a tree. So what you do here, because you're asked to describe, you're asked to describe here. So what you do is determine. First thing is determine. Now you have to determine. Now determine the ratio. Determine the ratio of the length of the students. Okay. Or let me say this. Or in a simple way, we can say that measure is the simplest way. Measure the height of the student. Measure the height of the student. After measuring the height of that particular student, then you come and measure the length. You can measure the length of the shadow of that particular student. Then the length of the shadow of the tree. Measure the length of the shadow of the tree. So you're having three things. So what you don't have is the height of the tree. Then you can use the formula. The formula that says if you take the height of the shadow, you divide by the length of the student. The length of the student. Then you are going to get the height of that particular tree. Then you divide by the length of the student. The length of the student. And this one will give you the height of the tree, and give you the height of the tree. Question 3. The figure 1 shows a building block that is placed on a blank grid supported by 2 pivots. So I have seen the block, the blank of the grid, and the question is on the diagram, show how tension of forces acts on the blank code. That's a question. So you will see some kind of some forces, others like that, and others like that. You can see others like that. That's how you can easily show the tension forces. As simple as like that. Question 3, 2 spanners that used to loosen a nut. Explain why spanner B will require less force. They require less force when loosening the nut. Remember, this is a question that is asking from turning effect. So how should you go about this? So what you do is that this is Yes, there's some questions which are missing here, but it's okay. So for question 7, some questions are missing, but it's okay. So here is that B has longer handle, a longer handle. B has a longer handle, and because it has a longer handle, then we are expecting to have longer perpendicular what? Hence longer, it is having longer perpendicular, hence longer perpendicular, you have longer perpendicular distance, hence longer perpendicular distance, then there is less force. Use less force to produce that less force will produce the some moments or the turning effect, like that. So the longer the handle, the lesser the force. So it increases the perpendicular distance, and that is why B will require less force when loosening the nut. Explain why ball is said to be unstable. You look at the ball, it is oval in nature. So the reason why specific that the ball is unstable is that when the ball is slightly pushed slightly pushed or displaced, a force is applied in it, and you see the line through its center, the line through its center, the line through its center of gravity, the line through its center of gravity falls outside the base, and that's why you see it falling, becoming unstable. So that's how we describe when something is unstable. A student required to calibrate spring balance by use of measuring height other than the spring mass. Name other apparatus are used to calculate the spring. We can use a ruler. Yeah, we can use a ruler, a meter rule. We can use even a graph paper. Okay, graph paper also can work. Can use a graph paper there. Yeah, you can use even a stand. It is observed that a vehicle traveling on a dusty road particles trail of dust rising high above the ground. Explain this observation. This question is coming from a question in a topic we call fluid flow. That is what we are expecting this question is coming from. So what happens here specifically is that the air below, just the air below the vehicle, has higher velocity, hence reduces what? Hence reduces what? Pressure. hence reduces pressure. So the pressure difference, the pressure difference, the pressure difference, the pressure difference lifts the dusts, lifts the dust, lifts the dust up. As simple as like that. As the velocity of the air increases below the vehicle, it means it reduces pressure. And the moment there is pressure difference, when you're talking pressure difference, we are talking about pressure and the atmospheric pressure. So the atmospheric pressure is the one that makes those dust particles to lift up high above the ground. An object moving with an initial velocity 3 meters per second is uniformly decelerated. What is here decelerated? To a stop after moving through a distance of 10 meters. Determine its acceleration. That's the question. So this is from the question of linear motion. So we have an equation that we are talking if v squared is equals to u squared plus 2as. But in this case, we are having, it is decelerating. So we are having our v is going to be 0 squared. Our u is going to be 3, you have been given the initial velocity, plus 2 times acceleration. Do we have the speed? We have the acceleration as 10, but we don't have the speed. We don't have the speed. So having s here. Don't have it is 2as. S is the displacement, which is 10. So, oh, sorry, is okay. Then, so if you substitute up, you end up having that our A is going to be negative 45 meters per second squared, meters per second squared, a symbol just like that, right? Number 12. The student placed a coin on a smooth cardboard which was stopped on the glass peak. Then the cardboard was then suddenly pulled horizontally away from the beaker. State and explain the observation that is one does. That is an inertia. That is from the topic of Newton's law of motion. So what happens here is that if you pull out a coin in very fast, you realize the coin will not go away with the cardboard. So the coin will just fall inside the glass beaker. So you say the coin falls into the empty glass beaker. Why did you think so? It is due to what? Inertia. Due to inertia, the coin tends to remain in its. The coin tends to remain in its state. In its state. That's why the coin falls into the glass. State one source of non-renewable. These are the energy that cannot be renewed. It only if it is exhausted, is exhausted. So some of the sources that we have something like fossils. Okay, we have something like biogas. We have something like dry cell. Okay. We can have something like nuclear energy. All those are some of the non-renewable energy. Now, number 14, explain why a person trapped inside a smoke-filled room is filled with a crow along the floor towards the exit. So these are questions from thermal expansion. Thermal expansion. Remember, when you hit some air dust particles or some smoke particles, what happens? They expand and they become light. So what happens here is that you say smoke is less dense. Smoke is less dense. Is less dense. Smoke is less dense than air. Hence, rises. Hence, it rises up. It rises up. It rises up. Okay. It rises up. Or you say, cool, denser air replaces the smoke. But when the smoke is less dense than the air, hence rises up or becomes light when heated. When heated. Stroke when hot. Okay. Right. So that is it. So the moment you heat the smoke, those particles of the smoke become less dense and they raise up and they raise up and they rise up. Now I want to go to section B. Answer the questions in these spaces below. Question number 15. State the meaning of specific latent or specific heat capacity. Specific heat capacity. This is the amount, or this can be the quantity of heat, amount of heat required, the amount of heat which is required to raise temperature, to raise temperature of the unit mass, temperature of the unit mass of a substance, Whenever you are defining a term in physics, try to define it from as it is in the Kelvin. Question B, a student observed that when ice cube is placed in water, it melts. Explain this observation. So these are ice cube, you put it in water, it starts to melt. So you have to talk of the specific heat capacity that the water has and the ice have. What happens? Which one gains heat? Which one loses heat? That's what you are supposed to have in mind. So you say water provides the heat required, which is of course required to overcome, the heat which is required to overcome the latent heat, of ice, hence the ice melts, like that. It can provide latent heat of fusion. Let me write that. latent heat of fusion. Okay. Now state two ways in which melting point of the ice can be reduced. So we can reduce the melting point of the ice by increasing. There are two factors that affect that. So we increase the pressure, or as well, we can add some of impurities. You can add some impurities. So you can add something like salt. A block of ice at 0 degrees Celsius is supplied with 2000 joules of heat. Determine the mass of water that will melt. Specific latent heat of fusion for ice is given as 3.36 times 10 to the power 5 joules per kg. Now, having two things, that is the heat which is applied, the ice is at 0, you're supposed to calculate the mass of water that will as well melt. We know that to get the quantity of heat is going to be getting mass times the latent heat of vaporization. Latent heat of, not vaporization, but fusion. Latent heat of fusion. Latent heat of fusion, because we are given the specific heat of fusion for the ice. Now, we have to calculate the quantity of heat here. We have 2000, which is going to give us mass multiplied latent heat of fusion 3.36 multiplied by 10 power 5. So to get mass, you only take 2000, then you divide by 3.36 times 10 to the power 5. So what do you have with your calculator? So if you calculate that one in your calculator, you ending having 5.952 multiplied by 10 to negative 3 kgs. You have that one. Have something like that. Part D, a student mixed 25 grams of hot water at 50 with 75 grams of cold water at 20. Determine the final temperature of the mixture. Again, here you have to understand that heat gained is equals to heat lost. The thing you have to have in your brain. So what you say, the heat lost will be equals to heat gained. You have to know that in your brain. So how do you find the heat lost? So you have mass times specific heat, latent heat or capacity, times change in temperature. You get the same as the mass 2, let me say mass 1, latent heat capacity times particular temperature. So I'm having 25 over 1000 multiplied by 42,000, given that, multiplied by 50 minus t. Will give me the same answer as if you take 75 over 1000 times 4200, okay, then multiply by t minus 20. So because of the space is very small, if you work that, you find let me work it. I put the answer there because the space is very small. you'll get 27.5. You get 27.5 degrees Celsius. Now, a student of a certain school wants to verify Boyle's law. State two operators the students need to verify Boyle's law. So number one, that student particular must use a pressure gauge. That one is to measure pressure. Then he must have a measuring cylinder or a measuring scale. A measuring scale. Okay. He must have something like air pump. Okay. Air pump. State one quantity will be kept constant, and this is Boyle's law. Then temperature must be kept constant. Temperature must be kept constant. And also, of course, mass. Yeah. Now, it shows an operator that used to investigate the rate of diffusion of two gases A and B, which form a white deposit when they interact. Okay, gas A and gas B. We are asked identify the gas that diffused faster. It is gas B. Gas A, gas A diffused very fast. Why do you think so? So when you're talking of diffusion of a gas, the rate at which it diffuses, how light is the gas? So the one that covers longer distance here, this distance and the other distance, this one is smaller. So this one is big, and therefore that's why it means the gas diffused faster, because it is less dense than gas B. State one way of increasing the rate of diffusion of two gases in. So what you do here, you only say you try to increasing. So increasing the temperature. So those particles move very fast. So increasing the temperature, that is the best answer you can give. Explain Charles' law using kinetic of gases. So the key word here, students, is kinetic theory of gases. And we are explaining this one using Charles' law. So you say remember, when temperature increases, what happens is that the particles move fast, or gain kinetic energy, when they gain kinetic energy, they move very fast. After gaining hence they make more collision. They make more collision by unit time with the walls. Of course, with the walls of a container. With the walls of a container. Okay. With the walls of a container. Okay. Increasing the rate of change of momentum. Increasing the rate of change in momentum. Change in momentum. So when you explain this one, you have to explain how those particles, when temperature increases, they gain kinetic energy, and that one makes those particles to collide with the walls of a container, increasing what? The rate of change of momentum. The volume fixed mass of a gas is 20 cubic centimeters at a temperature of 19 degrees Celsius. Determine the volume of the same mass of gas when the temperature increases at 24 at a constant pressure. At a constant pressure. So this is a question. So the formula I want to use here is that we are having what is constant here, it is pressure. So if you want V volume 1 over T1 is equals to volume 2 over T2. So we are looking for the volume of the same volume 2. So to get V2 is going to be V1 T2, then U divided by T1. So then you substitute volume 1, 20, multiply by temperature 2. You have to change it to temperature to Kelvin by adding 19 plus 273. To add that when you get around 292, 92, you divide by temperature 1 is 24. If you add 24, you get 297. Yeah, 297. Then after you calculate that one, no, this one is supposed to be 297, and this is 292. 297, 292, right? So if you calculate in your calculators, you end in having, this is 20.34 centimeters cubed as the volume. Indicate on the diagram the angular displacement theta. So this is a circular path of radius r, and you're given an object moving from point A to B in a time t seconds. So you're supposed to indicate it up there, the angular velocity. So we have the angular velocity, and we're having the linear displacement. So linear displacement will be somewhere here. Linear displacement will be somewhere here. And we have the angular velocity will be here, just an angle like that. Okay, don't worry, it has this question 70 is not complete, but we are going to have it. Then question number 18 is saying state the Archimedes principle. That's a question from floating and sinking. Very much important, and this is the question that most of the time makes students have headache. Now, Archimedes principle, it states that when the body is fully or partially, can be fully or partially submerged or immersed in a fluid. In a fluid, it now experiences an upward force. It experiences an upthrust force equal to the weight of the fluid. Equal to the weight of the fluid displaced. Okay. To verify, recommended spritz per student is provided with water in a measuring cylinder, solid metal, piece of thread, spring balance, and you're supposed to describe how the mass of water displaced may be used using these kind of apparatus. Now, how do you use those apparatus to calculate or determine mass of water displaced by a measured apparatus? So what you do, number one, you should record. Number one, you have to record the volume of water. The volume of water. The volume of water in a measuring cylinder. So because we have that measuring cylinder, so you have to do that. Then after measuring that one, you immerse the solid. Immerse the solid metal. The solid metal into water. Into that particular water, and record the new. And record, of course, the new volume. The new volume. Then after doing that, you determine. Now you are able to determine the volume of water. Determine the volume of water displaced. Displaced. Okay. Displaced. So using the volume of water displaced and the density of water, you are able to determine. Hence, you can say mass is equals to volume multiplied by density. So that's the final way you can find the mass. Now you have the volume and you have the density of water. You are able now to find the mass. I recommend espresso may be verified. How do we verify using those apparatus again? So what you do here again, because that is second one, is just you determine. Here you are supposed to determine. Because you are given the apparatus, determine the weight of the displaced water. Determine the weight of displaced water. And after doing that way, determine the apparent loss in weight. You determine the apparent weight. Okay, the apparent weight. Determine the apparent weight of the solid metal. Of course, of the solid metal when in water. Okay. Then from there, to get now the apparent, apparent weight, is given as you take the weight of the air. Sorry, you get the weight of the air. You subtract the weight of the water. Like that, you get the apparent weight. Then apparent loss is the same as the weight displaced. Remember that weight replaced by of course by water. Now part C, state one way of reducing surface tension in liquids. So how do we reduce surface tension in liquids? Number one, you can add impurities. Okay, like sabuni, impurities. Number two, you can increase temperature. You can increase temperature. increase temperature. It was observed that when a certain object is placed in water, it gets fully submerged. However, when the same object is placed in glycerin, it is partially submerged. If you look at the two, that is true. You ask to explain the differences between the two, the differences between the two. So here you have to talk of density of the two. No, density of glycerin, density of glycerin is greater. So the word here is greater. It is greater than that of water. Than of water. So density of glycerin is greater than that of water. So the body is floating in both liquid, hence they experience equal upthrust. So the body displaces more volume, hence the body displaces more volume of water. More volume of water than glycerin. Glycerin. As simple as like that. Number 19. A stone and a piece of paper are raised from the same height in a vacuum. It is observed that they both hit the ground at the same time. Explain this observation. So remember the word here is a vacuum. Vacuum here, in a vacuum there is no force of gravity, and therefore we are expecting the two, even if the paper is light and the stone is heavy, they reach and they run the same time because of the force of drag just downwards the ground. So number 19, we are going to say they both bear accelerated with constant gravitational acceleration, constant gravitational force. Okay. Hence no air resistance. Hence no resistance like that. A car of mass 1560 kg traveling at a velocity of 25 meters per second is brought to rest by a constant force of 3000 newtons. Determine the change in momentum. This is a question from Newton's law of motion. How do we do change? Change in momentum is you take, momentum is mass times velocity. So you get mass times velocity, mass times initial velocity. So we are having 15,000. We are having 1560, right? 1560 into, we have 0, we subtract 25. So what is the answer? So if you have that, you are going to have negative 39,000. 39,000. This is NS. Right, time it takes for the car to come to rest. So you know Ft is going to give us mv minus mu. Already we have done it. So in this case we have a force of 3000. T is going to give us negative 39,000. So to get T is when you divide both sides. So 39,000 you divide by 3000, and the answer you are going to get is just 13 seconds. 13 seconds. Jane measured the length of a palm of her hand as 18.7 centimeters. Describe how the palm length may be used to estimate the length of a laboratory table top. Okay, so it's using a palm and it's measured as 18.5. You are just describing how it's going to estimate the length. So here you do measure. What you can do here is to measure, or you can count. You can say count the number of, that is palm, the palms in length. Okay, transferring the palm length along the table, of course along the table. So that means the length of the table is going to give us the number of those palms you multiply by 18.7. Okay, explain why the estimated length of the laboratory tabletop in Roman 1 is not accurate. Why do you think this one is not accurate? Because there is parallax error. Can be parallax error or an error in transferring the lengths due to shift in position. That is a parallax error. And the complete palm, okay, can be under complete, of course, can be complete palm length, the palm length. Okay, inaccurate measuring even the length of the palm. So that is also it can be inaccuracy in measuring the length of the palm. Yeah, that is it. Okay, so that is the end of physics paper 1, although there were some of the questions which were not available here. I look for them, then also I come and revise with you. So thank you very much. You can subscribe, you can like, also you can as well share with others. God bless you. Thank you.